Hi guys, welcome back. Mrs. Saunders here. Today we're going to learn to prove that two triangles are congruent. Now we already know that if all parts of a triangle are congruent to the corresponding parts of another triangle, then the two triangles are congruent. But it's possible to use shortcuts to prove congruence. And we love shortcuts. So we're going to study 4 of the shortcuts, 2 of them today, 2 of them next time. But let's start with an overview of what the 4 shortcuts are. First is the side, side, side shortcut, meaning if you have 3 pairs of congruent sides, the triangles are congruent. If you have 2 sides and an included angle that are congruent, so 2 sides and an included angle, then you know the triangles are congruent. If you have 2 angles and an included side, so there's 2 angles and then the side between them, then that would work as a shortcut to proving that the triangles are congruent. And finally, 2 angles that are congruent and then a side that's not between them. That would also work as a shortcut. So before we dive into actually proving that 2 triangles are congruent, let's see if we can just recognize which of the shortcuts we would use in a couple different scenarios. So which shortcut would work for these 2 triangles? Well, what do we have here? We've got 2 sides that are marked congruent, right? And then the angle that's between them. So 2 sides, see here, 2 sides, and the angle between them. So that's the side, angle, side shortcut. All right, what about these? All 3 sides are congruent, so that's the side, side, side shortcut. All right, now this one, we've got 2 angles that are marked, 2 angles that are marked, and a side between them. So look at, 2 angles, and then where's the side that's congruent? It's between them. So that's the angle, side angle. And then this one, 2 angles. Okay, and then the side that's congruent is outside. It's not in between those 2 angles. So that's the angle, angle, side congruency. And just for a minute, let's compare those 2 because these 2 are so easy to get mixed up. But again, if we've got 2 angles that are congruent, where is the side that's marked? Is it between them? In which case the S is in the middle, angle, side angle. Or if you have these 2 angles and the side that's marked is not between them. In this case, then it's angle, angle, side. So just look at that for a sec. Make sure you can kind of tell the difference between them. All right, so now a proof. Geometry is known for proofs. And to be perfectly honest, most people think they're a little bit terrifying. But just stick with me and I'll walk you through how to do these. A geometry proof is an argument that begins with known facts, proceeds from there through a series of statements and reasons, and ends with the thing you're trying to prove. So one proof might look something like this. This is a completed proof, and you can see we start with some given information, we go through a series of statements and reasons, and then we end with something we're trying to prove. Now, the tricky part is how do you know what all these statements and reasons should be? All right, well, I'm going to start by giving you a little bit of a menu for different kinds of reasons we could have, and then I'll work you through the statements a little bit later. So, reasons for congruent sides. This is a menu that you'll get to choose from. Number 1 reason, it's given. In other words, they just tell you. Could be the definition of a midpoint, because a midpoint creates 2 congruent sides. Could be the reflexive property, meaning that a side is congruent to itself, which I know sounds weird, but I'll show you what that looks like. And then reasons for congruent angles is given, they just tell you. Vertical angles, we know that vertical angles are always congruent. We could have alternate interior angles or corresponding angles. Now be careful, those both require parallel lines, so be on the lookout for some parallel lines. And then a definition of an angle bisector, because similar to the definition of a midpoint, a bisector will create two congruent angles, okay? And then finally, CPCTC, which means corresponding parts of congruent triangles are congruent. We're going to get to that in another lesson. So here we go. We're going to dive in to our first proof. Okay, now with any proof, let's just read it first and see where we're going. So we're given that PQ is congruent to ST, QR is congruent to TR, and R is the midpoint of PS. That's our given information. And what we're trying to prove is that triangle PQR is congruent to triangle STR. Let's start by working through some of this given information. So PQ is congruent to ST. Well, the first thing you're going to want to do is mark that on your figure. Marking it is going to keep all the information straight in your brain so you know what's happening. So that's also our first statement, that PQ is congruent to ST. And how do we know that? What's our reason? Well, because they told us. It's given. Then we've got QR is congruent to TR. Again, mark that on your figure to keep your brain organized. And then that here is the second statement. And the reason, again, is because they told us. It's just given information. And then next, we've got R is the midpoint of PS. There's not really a way to mark that, but I'm going to put a dot there to remind myself that R is the midpoint. And then that's the next statement. And the next reason, of course, is that that's given information. So the first part is usually pretty straightforward. You write down the given information, mark it on the figure, and for each of the reasons, you just write given. All right, now the next statement that they're telling us is that PR is congruent to SR. So let's go ahead and mark it. PR is congruent to SR, but how do you know that those are congruent? Well, you know that those are congruent because remember we put this dot here to remind ourselves that R was the midpoint, and a midpoint creates two congruent segments. So we're going to write that the definition of midpoint is the reason we know that those segments are congruent. Now you can look at the two triangles, and what do you have? You have three sets of congruent sides. So that's the side, side, side shortcut. Okay, let's try another one. We'll try to go a bit faster. First thing you do is read it. JL is congruent to NM, and K is the midpoint of JN and LM. And we're going to prove that JKL is congruent to KN. Nope. JKL is congruent to NKM. So you see it like there's so many letters going on. That's why it's so important to start marking and go slow, because otherwise you just end up swimming in alphabet soup. Okay, so let's start with the given information. JL is congruent to NM. Make sure you mark that down. That's the first statement. And then the first reason, of course, is because that was given information. And then K is the midpoint of JN and LM. So I'm going to put a dot there just to remind myself. And then reason number 2 is given. Okay, next it says JK is congruent to NK. That's not given information, but let's mark it. JK is congruent to NK. And how do we know that those are congruent segments? Because K, that dot we put here, is the midpoint. So the reason we know that those two segments are congruent is because the definition of midpoint. And then LK is congruent to MK. We'll mark those. Same reason, definition of midpoint. And now we have 3 sets of congruent sides. And our reason that those two triangles are congruent is because of the side, side, side shortcut. Now the next one we're going to do is blank. No statements, no reasons. First thing you're going to do is read it. So AC is congruent to AD, CB is congruent to DB, and we want to prove the triangle ABC is congruent to triangle ABD. All right, we're going to start, just like we did before, one by one with the given information. So AD is congruent to AC. Let's mark that there, and the reason is because it was given. Okay, we have another one. CB is congruent to DB. Write it down as a statement. Mark it on your figure. The reason we know that is because it's given. Okay, now what do we do? Here's a trick. When you have a blank proof, you know what you're trying to prove. So you can always just write that in the last spot. That's where we're going. So let's write that down. You don't always know how you're going to prove it, but in this case, they told us. We're going to use side, side, side to prove that these two triangles are congruent. So we can write that down as our final reason. All right, but now what about statement 3 and reason 3? We're supposed to be using that side, side, side is the shortcut. Right now, if we look over here, we've got 2 sets of congruent sides. We need a third. Well, the third is right here in the middle. See AB? They share that side. And if they share the side, well, then the side is congruent to itself. That's weird, but hear me out. So AB is congruent to AB. That's our statement because they share that side. And the reason is the reflexive property. Seems a little silly to write that down, but it's important to cover each piece of information you need in the proof. All right, we're going to move on from side, 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 and now we're going to use some side, angle, side shortcuts. All right, so JM is congruent to LN. I'm going to mark that down, write it as given, and angle JMN is congruent to LNM. Mark that down, write it as given. Now the next statement they told us was MN is congruent to MN. That's the trick we just learned in the last one, right? That's the reflexive property. And now the triangles are congruent. How? Because we've got 2 sides and an angle between them that have been marked congruent. So that's side, angle, side. Couple more. I know this is a long lesson, but please stick with me. Okay, AB is congruent to CB. Given and marked. BD bisects ABC. That's given information. How do we mark it? Well, again, like the midpoint, there's not really a good way to mark it, but I could highlight it for now just to remind myself that that's a bisector. The next statement, number 3, they say that angle ABD is congruent to angle CBD. So let's mark that. How do we know that those are congruent? Well, it's because of that bisector that we put in there. A bisector cuts an angle into 2 equal halves. So our reason is because of the definition of an angle bisector. All right, now BD is congruent to DB. That's statement number 4. That's the reflexive property. And then again, we've got triangles are congruent because of the side, angle, side shortcut. Getting close to being done here. I think we have 2 more and then some speed rounds. So V is the midpoint of WZ and XY. So that's given information. I'll just put a dot there to remind myself. VW is congruent to ZV. Let's mark that. The reason we know that is because V is the midpoint. All right, statement 3, angle WVX is congruent to angle ZVY. How do we know that? It's not given information. Those are vertical angles. Vertical angles are always congruent. And then it says, statement number 4, XV is congruent to YV. That's because, again, of definition of midpoint. And then I've got 2 sides and an angle between them. Okay, one more proof. Stick with me. The reason we're doing so many proofs is because you just have to see it over and over and over again to really get a feel for what's going on. And in this one, I want you to pay special attention to something. So we're given that HI is congruent to JG. All right, so we're going to mark that. And then it says HI is parallel to GJ. All right, you can mark that with 2 little arrows. And that's going to be important because remember that menu that I told you at the beginning of the lesson? There were 2 things that required parallel lines, alternate interior angles and corresponding angles. So we need to be looking for those 2 types of angles. Now it says GJH is congruent to IHJ. So let's mark that. How do we know that those are congruent? Well, this is where the parallel lines come in. 2 parallel lines cut by a transversal, those are alternate interior angles. And then we've got HJ is congruent to JH. That's the reflexive property. And now we have our side angle side shortcut. Almost done. We're going to do a speed round here. Okay, so state whether the triangles can be proven congruent, if possible, by side, 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 or side angle side. So first one, we've got two sides and an angle between them. Side, angle, side. This one, we've got two sides, and that's all that's marked. But we know that we've got this third side with the reflexive property. Now we have all three sides we need for side, side, side. Okay, 3. There's a lot going on here. Okay, so let me show you what the two triangles are. We've got this blue one, and then we've got another green one. And they've got the sides marked and an angle marked right there. And then they share this third side. See that? Okay, so then we've got a side, angle, side shortcut. Okay, these two, we've got two sides and an angle not between them. That's actually not in our shortcut list, so that is not possible. Okay, number 5, we've got another side, side, side. Number 6, we've got parallel lines cut by a transversal, which means we've got some alternate interior angles. And then we've got side, angle, side. And then let's see, number 7, we've got two sides and an angle not between them. That's not in our shortcut list. We don't have a side-side angle. That's not a thing. And then finally, number 8, we've got vertical angles. So we've got two sides and an angle between them. Okay, I know that was a lot of information, but thank you for sticking with me, and I will see you next time.